In this lesson, we're going to learn how to factor binomials. At the end of the lesson, you should be able to answer the question, how do I factor binomials using the difference of squares pattern? So let's examine a few binomials where we're multiplying together to see if we can notice a pattern. So in the first one, x minus 4 times x plus 4, you should know the FOIL acronym, which says first do x times x, which is x squared. Outer would be plus 4x, inner would be minus 4x, and last would be minus 16. Then I combine the two middle-like terms and I notice that they cancel, which results in x squared minus 16. In the second one, again FOIL, 2x times 2x would be 4x squared. Do the outer product would be 2x times positive 3 is positive 6x. Now I need to distribute this negative 3. The inner product would be minus 6x, and the product of the last would be minus 9. Again, I notice that my two middle terms drop out, and I get 4x squared minus 9. In the final one, 2a plus 3 times 2a minus 3 is very much like the last one. This would be 4a squared. Outer would be minus 6a, inner would be plus 6a, and last is minus 9. It's really just the variables that are different. I should have picked a better example here. That would be 4a squared minus 9. So what do you notice? Hopefully you're noticing that in the simplified answer in all three, the middle terms drop out. And why is that? Well, if you look at the original two binomials, they're identical except for a sign switch. So what we're going to be doing is going the other direction. I'm going to give you a binomial that looks like this, and you've got to come up with the factored form, which would be like the x minus 4 times the x plus 4. So based on this, the pattern for the difference of squares, and it's called the difference of two squares because if you have a perfect square minus another perfect square, it is always going to factor into two binomials where one is a plus, the other is a minus, and you take the square root of each. So a and b. So one will be a and the quantity of a minus b. So let's try factoring some. So first of all, x squared minus 16. It is a perfect square minus another perfect square. So this, I open up two binomials. One factors into the square root of x squared would be x. One's a plus, the other's a minus, and the square root of 16 is 4. It's factored. The second one, again, it is a perfect square, and 121 is a perfect square, so I take the square root of each. The square root of 121 is 11, and the pattern says one's a plus and the other's a minus. And if you want to check at any point to make sure you're not making an error, you would just FOIL back together. 4x squared minus 81, again, 4 is a perfect square, so is x squared, and so is 81. So factors into two binomials, one being a plus, the other being a minus, and they're identical in the other ways. So square root of 4x squared would be 2x, square root of 81 would be 9. Okay, let's look at number 4 here, square root. First of all, is it the difference of two squares? It is a subtraction problem, so it is, and it's going to factor into two binomials. Take the square root of 9x squared would be 3x. Square root of y squared would be y, and the pattern says that one is a plus and the other is a minus. In number 5, it's getting slightly more complicated, but you still ask the same questions. Is it a perfect square minus a perfect square? And square root of 25 is 5, square root of c squared is c. So 5c, square root of 36 is 6, square root of d squared is d, so 6d. One's a plus, the other is a minus, by the difference of squares pattern. Now, number 6 is a great one, h to the 4th. Well, is that a perfect square? As long as it's an even exponent, you can take the square root. The square root of h to the 4th would be h squared, because if you think about it, this would be h squared times h squared. You would keep your base and subtract your exponents. And somehow I erased my screen, but that's all right. I'll just rewrite this. So it would be h squared plus 10 and h squared minus 10. Now, what you should do is always look and check and see if you have the difference of two squares pattern again. Well, the first one's a sum. The second one, it is a minus. The first one's a perfect square, but 10 is not, so that's as factored as it will get. Number 7 is an application question. It says a rectangle has an area of 25x squared minus 64, it should say units. Write the length and width as binomials. So if you're being asked what is the length and width, think about what concept is here. Well, it's area. Area is found using length times width. So we know the area. It is 25x squared minus 64 units. It's a polynomial. So we need to figure out what the length and width are, so it's going to be two things multiplied together. Well, how do we find what two things they are? We would have to factor it, and it's a binomial, so you check for the pattern you now know, the difference of two squares. The square root of 25 is 5. The square root of x squared is x, so it's 5x. Square root of 64 would be 8. One is a plus and the other is a minus, so it would be 5x plus 8 and 5x minus 8. Now, it really doesn't matter which one you call the length and the width, because if you turn a rectangle, what was the width could become the length. Now, there are no units, so I generally just write the word units. Okay, so hopefully you are now able to decipher or identify the difference of squares pattern and apply it. Okay, for a final, a final example, just want to show you what might occur. Let's say that you are given one that is 25x squared plus 4. A lot of times kids will try to make this be the difference of two squares, but this, notice, is a plus sign. This is not factorable. And if you tried to apply the difference of two squares, making it 5x plus 2 and 5x minus 2, and you FOIL back together, you would see that you get 25x squared minus 4. They're not equivalent. So when it's not factorable, we say that it is prime.